Just brief introductions here, and then I'm going to turn it over to our panelists and our moderator and our panelists. As I mentioned, I'm Michael Martin. Thank you for joining today. I lead communities here at Signalfire. Signalfire is a venture capital firm. We're based in the Bay Area, and we invest in early and growth stage startups. Today, we are more than excited to be hosting this virtual event with Niall Murphy and Tina Huang. They're old friends of the firm. Tina is the CTO of Transposit, and Niall is SRE lead at Microsoft and Azure. And we host these events on a regular basis, about once a month, for around DevOps specifically. We have a DevOps community, so we've hosted a few in the past, and we'll continue doing these on a monthly basis. So thank you for joining today, and you'll now be on my mailing list for any future events that we have. So I'm looking forward to your questions. Please ask those in the chat. Today we're really just going to start with Stephen Trusheim from Signalfire as well, who do his own introduction, moderating this panel. And then after about 45 minutes, we'll just open it up to Q&A. So throughout this fireside chat, please feel free to put your questions in the chat. And then once we go into Q&A, you can feel free to turn on your video and microphone and ask there. So I will ask that you remain muted throughout the panel discussion, but after that, we can feel free to open it up. So with that, Stephen, do you want to go ahead and kick things off?
I would love to. Thank you, Michael. And first of all, I want to thank Tina and Niall for being here today. I'd also like to thank Tina. This is a fireside chat, and we do have a fire in the background there, so that's a great start for our day here. Tina is the co-founder and CTO of Transposit, and as a software engineer, she used to build infrastructure services and frameworks at tech giants like Apple, Google, and Twitter. She was also a founding engineer at Sigma Computing and an EIR at Sutter Hill. And Niall, as you heard, is the Azure SRE lead, and he's written the co-author of numerous best-selling and award-winning books, including Site Reliability Engineering. He's one of probably the few people in the world that holds degrees in computer science, mathematics, and also poetry studies. He lives in Dublin, Ireland, so thank you for being with us all the way from Dublin. I know that borders and also time are meaningless in this day and age, but here we are anyway. So I wanted just to start with getting to know you a little bit better. So I wanted to maybe start with Tina. You know, we're all in the world of DevOps and SRE here. At Signalfire, we invest a lot in DevOps and SRE tools, including myself here at Signalfire. But I just wanted to hear your favorite on-call story, just to kind of warm up and get to know each other a little better. Tell us your craziest story, your funniest story, whatever you'd like, Tina.
Yeah, I wanted to start with I don't know if I could say it's my favorite, but it's by far the most memorable on-call story, which was, one of the very first times I was on call at Blogger. So, there's so many challenges when I joined Blogger, but, for one, it was a bunch of Windows boxes in Google, and Google didn't trust them at all. So all the boxes were in a physical cage, and, there were like crazy nuances, such as the cage ran out of power, and we were trying to migrate over to Google infrastructure, but in the interim, we had to keep Blogger afloat. And so anything we wanted to do to actually fix the underlying causes, we'd have to make trade-offs because you had no more power. So it's like, okay, you want a new load balancer? Well, what are you going to be willing to give up in order to make that work? But on top of that, I went to school at MIT, and then my first job out of school was working on the operating system at Apple. And so that meant that I was very familiar with Unix, but didn't know Windows at all. So the learning curve for being on call was super challenging. I had last used Windows when I was in high school, which was something like Windows 95. Our development machines were Macs. So that also meant we didn't have practice using the machines that we had to debug on. And so even things like the first time I was paged, I didn't know how to pull up a terminal, but that was not something that I even thought to ask someone before, going on call. And so, some of these early on-call incidents with Blogger, I say they're memorable, but it was almost like PTSD. But I think that it's really rooted in why Transposit does what it does, when we think about what it means to be thrown on call. So one of the very first incidents happened. I was paged, and I think I restarted a server or something, and went to blogger.com, seemed like everything was up, went back to sleep. I come in the next morning and my boss is livid. So it turns out that, while Blogger was up, publishing was down. And this is one of those common things where it seems so obvious in hindsight, but when you check that the service is healthy, you got to check the read and the write path. And I like to lump these things into the category of what I call sensical, but not common sense. I think we often confuse those two where, when somebody, it's like in hindsight, it's like obviously read and write path, but, at 2 a.m. in the morning, but also just for the junior engineer who has never had to operate a web service that may or may not be intuitive. And, much later on, as I was running Transposit, I even saw this mistake happen with a very senior SRE of ours, who we were paged in the middle of the night. He looked at the graphs, quickly assumed that it was based off of the deploy because of the timing, saw the metrics heal themselves, and then went back to sleep. And he, yet again, forgot to actually go to the site and validate that the site was up. And so, this is sort of at the root of, the PTSD that I got from being on call, why I would never actually become an SRE. So Niall, kudos to you for taking on that stress and that risk. But also why it's so important to me to think about how can we better prepare people for having to be on call.
I think you're muted, Steve.
Sorry, I can't unmute. I didn't have the power there. I apologize. I'd like to ask the same question to you, Niall. Just tell us your favorite, most memorable, craziest on-call story.
Yeah, I think I'll first of all echo Tina's comments that favorite is maybe not quite the right adjective or problem in this domain for all kinds of reasons. And I mean, I'm on record in an article called Against On-Call that today on-call resembles emergency medicine as opposed to ward medicine, and we should be looking kind of industry-wide to move our systems towards ones that admit a kind of ward medicine. But putting that to one side, there's actually two on-call stories I'd like to surface, and the first one from close to the start of my career in the 90s, late 90s, and the second one around 10-ish years ago, thereabouts. So the first one is, it's more of an observation really, which is about incentive structures, which is first thing I'm seriously on call for is an ISP called Ireland Online in the 90s. And at that stage, rack of Unix boxes, Dells as it happens with FreeBSD. And they were in an office building where the room they were in was shielded from the outside world by a rake of windows which had tin foil put in them and a portable air conditioning unit stuck in with a hose going to the outside world because the temperature control when the sun came in at the wrong angle was terrible. Anyway, like we did fine, but once upon a time there was a problem where a set of servers, and in particular website servers, essentially rebooted every night because of a fragmentation problem. They would get a lot of fragmented packets at that stage that would fill up some kind of kernel buffer, something would panic failover and so on. And I would have to come in physically at that stage, reboot stuff, et cetera, et cetera. Fortunately or unfortunately, this began my journey in understanding incentive structures because it turned out that in fact, every time I was summoned to go on site and fix something, that was an extra like 150 Irish pounds back when Irish pounds still existed. And I was saying to myself, like if I was clever, I would probably like write a script in order to give me an extra 150 pounds per day. But as it happens, I was not that clever and also sadly more moral than that incentive structure would lead you to believe. But the second on-call story relates to automation, actually, which is a story from my time in related teams to the ads database in Google, where there was a piece of automation which was used to update permissions, in particular kind of user level permissions. You know, when you go grant something on such and such a table to a list of users. in MySQL. The automation assembled the list of user changes that had been made by the user community and basically ran through all of the backend servers in order going, okay, drop these, then add these, fine. So it turned out that this ended up tickling a bug in MySQL, whatever version it was, 3 point something, I suppose, where once the actual thing to be transformed in the grant table ran over a certain size, MySQL went thunk. And of course, the way the automation was written was it would drop all permissions first and then update to the new permissions. So it went around dropping all the permissions serially in machine by machine and preventing the automation from actually logging in again and fixing it. So that was an interesting story.
Sounds a little gnarly. I'll ask you sometime, maybe a little later, how you actually fix that one. Sounds pretty challenging. But we're going to talk a lot about automation today, so that's a great segue. Let's all maybe share the same mental model about kind of how the world has progressed up to this point, and we can talk about the future after that. So, I mean, just over the last 5 or 10 years, let alone the last 20 years, we've seen some major changes in the way that we develop applications, the ways that we deploy applications. The stacks that we use to build them, the tools, and everything about it probably seems like has changed in the most modern and forward-thinking organizations. So maybe Niall, starting with you, what do you think are the most impactful changes that we've seen in that tooling and those application stacks, those kinds of things, and how they impacted this organization?
Yeah, it's a huge question. I guess depending on how far back you're going or exactly how much of a 50,000 foot view you want to take. Probably my one sentence summary is no one cares about the single machine case anymore.
Sure.
Like, the single machine is dead and has been for a long while. What we care about now is, or what we experience now is that your call stack is externalized across a large, essentially arbitrary number of machines. Your application, even if it is what they used to call embarrassingly parallel back in the old days, which means it can be kind of essentially linearly split and composed. Even if you are in that situation, there's still some kind of crosstalk. There's still some reason for the machines to intercommunicate, and in particular for debugging, state inspection, etc., observability, and distributed tracing, and all of these phenomena, which really only exist because of the multiple machine case and cloud environments. All of those are, I'm going to fairly confidently assert, essentially mandatory for doing anything significant these days. I don't mean to cruelly judge other people who aren't doing observability and say you're not doing something serious, whatever. You certainly are, but I think very much the direction of travel is that direction, and the single machine case is basically dead.
For sure. And Tina, do you have any sort of other views or other things you want to highlight in that kind of stack?
Yeah, I kind of have 2 different pieces I'd add here. One is, and this should go without saying, the move to the public cloud has shifted a lot of things.
Definitely.
But I think that what's interesting about it to me is that it's not just the fact that we have cloud managed VMs instead of VMs on our own hosted machines in infrastructure, but what the cloud has really meant, and this is what Google really paved the path towards, is increased efficiency at the cost of greater complexity. And so one of the ways I often think about this is the example of load balancers. Load balancers used to just be hardware load balancers, and the logic wasn't something that you would ever touch or have to deal with. You would just sort of restart the load balancer if there's a problem. And we've shifted to a model where we now have AWS ELBs and ALBs, and that application load balancing allows us to do much, much more sophisticated logic in terms of how we balance the load across the servers. But that means that if you're that ops person debugging why the load balancer is kicking off a particular machine or whatever, there's a lot more complexity there. But the other piece of that is this increase of SaaS tooling, and a lot of this is for exactly what Niall's just talked about, which is, you know, because we have multiple machines, aren't really focused on a single machine, we have this whole ecosystem of SaaS observability that sits on top of that we need to use to manage. And, you know, in general with SaaS applications, what we have is highly specialized applications, which are great, but anytime we need to transfer data between different SaaS applications, that's almost always a manual process. So, you know, the easiest example is I go to my observability stack, I look at Datadog or something and grab the graph, and I need to, you know, share that information with a bunch of members of my team in Slack, you know, maybe copy that information into Jira. And all of these things are highly, highly manual now. And so I think that that's one of the ways that we also have this opening for automation in the operations use case.
Yeah, for sure. And now you've really spent a lot of time, you know, in that kind of like move from, you know, perhaps on-prem and then into the cloud, and then of course to multi-cloud environments, and seeing this whole transition to multi-machine environments. How do you think that's changed the need for automation, or the adoption of automation, at least as SREs are trying to, you know, put a lid on this complexity and keep it down somewhere they don't have to pay attention to it anymore?
Yeah, another good question. I think a lot of this is sectoral, actually, to the extent that in the very beginning of the multi-machine transition, folks from the, I suppose, Microsoft background would be accustomed to automation coming with a product, or you buy a product to give you automation capabilities of various kinds, system management server, blah, blah, blah. And so if you're in a Unix background, or if you're experienced with the development of ISP style services growing from, we'll say, the mid-90s up to what the cloud is today, I think you probably have a very different perspective on automation, which is more continuous. But I think multi-machine automation comes into Windows with PowerShell and with cloud APIs, quite frankly, as well. But putting that to one side for a moment and concentrating on kind of unitary community view of this.
Sure.
The fact that today, from so much of software development is about the question of what you can successfully ignore. Okay, so you can think of object-oriented programming and so on, and information hiding as being questions about, as a software engineer writing an application, I can successfully ignore the fact that this object encapsulates some complexity for me. I can poke it to do stuff, and I can read from it to see what it did, and so on.
For sure.
But actually, these days, with the teetering stacks of software that we're all dealing with, the abstractions have gotten leakier and leakier as we have moved up to the multi-machine case, and we are attempting in some cases to treat that with a leakier abstraction of even leakier abstraction of an even higher level. And so the question of what we can successfully ignore as software engineers has become more nuanced, right? I think particularly for folks in a multi-cloud configuration where, aside from bare VMs, bare VM launching, unlaunching, etc., there's actually quite a significant degree of variation around what the products offer across the cloud providers. And you might go here for your data analytics, and you might go here for your storage, or you might go here for VMs or whatever. And so I feel that today, software engineers have probably, like genetically speaking, about the same amount of horsepower to wrestle with complexity that they had 10 years ago. But the increased levels of complexity and the increased leakiness of the abstractions have impaired productivity in one sense, probably on the debugging and system model building and so on side, and have increased productivity in terms of, well, you've just got a much massiver fleet that you can, in theory, move the levers on.
Makes sense. And Tina, you've been spending a lot of time with customers that are trying to deal with these leaky abstractions and these multi-cloud environments, that kind of thing. How have you seen it changing the need for automation, or the adoption of automation in these enterprises as you've been working with these SRE organizations recently?
Yeah, you know, I think what Niall's hit on, which is sort of the leakiness of abstractions, is at the center of everything. But a lot of it is not just the leaking. I mean, we're talking about lots of different leakiness, right? You're talking about the leakiness from the developer and the engineers and the product side into the operations of that stack, but also that model shifts the abstraction between what it means to run, say, a support organization and SRE. So if you imagine the old world, and this is something that we've been thinking a lot about, what are these fundamental shifts that have happened in the last 5 or 10 years? In the old world, what we had is these long bake periods. And when I started my career at Apple, we were shipping literally box software. And so we had these gold master dates. And so we had a month before that, which was very, very strict change control, very strict feature freezes, code freezes, et cetera. And part of that was because we knew that it was going to be months before we're able to even patch the code. And so, in that world, the support org is really there in order to help the user work around whatever problems there or figure out their user error. And, even when you move this to the web world, in the early days before Agile, you also had these long manual QA bake periods. Even in my early days at Google, we would have 2-week-long manual testing that happened because the idea of hot swapping some fix in line was, hard back then. And so, as a result, operations was also sort of operating on their own. And the expectation wasn't that the engineers had to be involved to figure out kind of a code change and a code deploy. And so we've just muddled the whole world where, a customer support ticket comes in, an engineer is, actively paged at that time. And, it's possibly a piece that is an infrastructure problem, but it's also just as likely an actual code problem that you have to fix. And so all 3 of these organizations have to work really, really closely together. But the other piece of this also means that, incidents are timely and critical in a way that they weren't before. So the expectation is now that when an incident happens, you better fix it within minutes or hours, not weeks or months. And so all of this pressure of having all of these people across the organization with different skill sets and also having a much stronger urgency and timeliness that fixes have to happen. All that, kind of muddles together to say you need a lot more automation to make this easier.
Well, it makes sense. And let's dive into a little bit of that muddling, because you touched on a couple of things, which is my mental model is that in the old world, IT kind of set up the machines and the engineers kind of wrote the code that goes on the machines. And there was maybe more of a separation of church and state than we see today with things like infrastructure as code, where engineers are making really the operational decisions in some cases about what kinds of machines to be running on what sorts of workloads, that kind of thing. And maybe, Niall, can you speak of this kind of like this ecosystem that Tina's been touching on about everyone having to work together and kind of blend together across the organization to think about how to achieve your uptime and your SRE goals?
Yeah, I think the first thing to say is I'll quote myself earlier in this conversation.
Sounds good.
Yes, always an authoritative subject. Quote myself saying the question, what can you successfully ignore? In some sense, is the core question. I think what the last couple of decades really have shown us is that in situations as complexity grows, you've leakier abstractions, generates more errors, complexity in general, harder for people to work with, error rates go up in various kinds or in various ways. That's all, I think, reasonably established. What has been a journey that we're in many cases still going on across the industry is that's a technical configuration, or those concerns are often in the primarily technical domain, but actually behind the scenes or below the line of representation, or however you put it, there's actually a social or organizational component to how to address this. And in particular, the thing we discover that decades ago, actually my research shows from about the 50s, when mainframes kind of became popular after World War II. In the 50s, this split between development and operations kind of originates and then persists on for decades. And we make the assumption that you can successfully split, that you can successfully ignore a given set of questions and address them to different groups. But it turns out actually you can't do that, or at least you can do it up to a certain point, and then after that, the abstraction that the split represents itself becomes too leaky for a modern organization to successfully make progress. And this is all about feedback loops. This is all about deployment time shrinking. This is all about stability ensured not by batching up changes and carefully controlling things and having a change control board and all of the wonderful stuff that Nicole Forsgren writes about in Accelerate. Thoroughly recommend that book if you haven't read it already. But rather by having frequent changes, by having smaller sizes of change, and by having feedback loops that aren't broken. If you're still in a position where your development teams and your operations teams are viewing the world in very different ways, and essentially the operational consequences of the constructed software are an externality, like in the economic sense, on the production team, and it's the operations team that kind of suffers, I suppose is the right word, then what you have is a product that is less good than it could be and less agile, actually, in the plainest sense of the word. So I strongly believe that a more holistic view, not only towards the construction of software, which I think is hugely important, because right now I see in the industry kind of feature development is hugely, hugely important. And then there's everything else, and everything else includes security, compliance, reliability, performance, et cetera, et cetera. But it turns out if you treat those hugely separately, and often there are kind of social components that come in here, like, are you over there allowed to tell me, the product developer, what to do, or like to what extent can different groups influence different stages of the software development lifecycle? All of those things are, in the DevOps world, kind of hopelessly or hopefully intertwined. And if we accept this, if we accept that actually we're searching for simplicity by drawing hard boundaries in things organizationally, socially, technically, but actually what we need to do is unify more. And that is why I'm running for president in.
Well, let's dive into that and try to get down to some brass tacks here. Then I'll stick with you, Niall. So, I mean, I think the dream of I think everyone's dream as a DevOps team is to have a night filled with dreams that are not of you waking up in the middle of the night and hearing the pager go off, kind of thing. That's the main dream, I think, of many DevOps practitioners. And a lot of times, for many different reasons, as you're saying, maybe the unity of the stack, maybe the ongoing search for those hard boundaries, we don't get close to that perfect end goal of we never have to wake up, we have an on-call team that never has to hear a pager go off. So what do you think the major issues are today, or what are the main challenges that organizations face, and how can they get closer to this level of never waking up, everything's automated, everything's perfect now? Running for president.
I'm not necessarily 100% sure I would couple everything's automated with everything's perfect. Like,
fair enough. Yeah.
Those are not necessarily the same thing. On the problem generating side, we obviously have everything to do with highly dynamic environments running an internet service. Like, as soon as you open a TCP port on the internet, you get stuff in, right? That's just what happens. So there's a lot of complexity and a lot of leaky abstractions that are involved in the running of services in general. I think I would choose to highlight two things specifically, though. The first one is that we actively do damage to ourselves in the organizational / socio-cultural end of things when, in the act of deciding to page, we are insufficiently, discriminating about what we'll choose to page on. often, like not always, right, but often in organizations and in teams, like whatever level you want to put it at, there are pages which happen because 3.5 years ago, somebody said, this might be a problem, I suppose, CPU high, and they write an alert. And now in the middle of the night, the CPU is high and you get a page and people silence it and move on. Because CPU high has not been clearly correlated with any individual incident since then, but it happened once, so we have to preserve it forever. So there's a lot of, I suppose, mental frameworks around the management of alerts and the generation of pages, which actually flow from kind of inappropriate conservatism about what is actually contributing to alerts. And I'm totally was in this camp as well. I was on a team that had a kind of CPU high, CPU very high, CPU really too high style alerts. And these were viewed as providing valuable intelligence for the product development team, which they may in fact have provided, but there was no need to actually page anyone about it. So I think that's my advertisement for SLO based alerting, which you can read in the upcoming SLO book from Alex Hidalgo. This has been a sponsored advertisement. And then the second thing I would choose to surface, I suppose, is that a lot of the time people are scared of automation, in particular senior decision makers, because they say there's some intuition, which I think is not wholly wrong, that the environment is complicated, that automation can end up kind of doing something bad as per previous discussion. And so like you're paying people to be on call, so they should be on call, damn it. And so you are addressing the complexity problem and the dynamic environment problem by throwing people at it. And the difficulty, of course, is that human attention is a finite thing, non-renewable resource. If you just treat your teams in this way, they eventually leave. Like it's not a great problem domain for human cognition to be applied to. And so that's where automation comes in as a support for human activity, and in particular, kind of the simpler things you can do to offset certain kinds of problems. There's 80-20 relationships there where a terrible thing happens to a data center, but your automation handles the redirection of the traffic automatically. You don't need to do anything about it. Nobody needs to be paged. It's ward medicine rather than emergency medicine. And you can look at the problem in the relative safety of the business hours.
That makes sense. And I can't tell you how many, I won't name names, but a number of companies I've heard of in my own portfolio and in others, their SRE teams have too many on-call alerts and they just burn out and leave. I mean, it's a terrible thing for the organization, of course. But it comes from the same kind of root problem. I guess, Tina, I just wanted to ask you just a broad question, which is, what do you think of what Niall just said? There's a lot of takes on automation and making the organization better. What do you think?
Yeah, I mean, to sort of just start with what Niles was talking about, where he's mentioning this 80-20 relationship with human activity and automation, I think that, that's the core of it. It seems counterintuitive, but the path to trusting and building more automation is focusing on smaller chunks of automation. So, one of the problems that you have is if you try to automate everything, it tends to be very, very fragile. It's hard to create that automation, that script. And, the worst case, and I think this is actually something that Niles mentioned in one of our kind of chats earlier, is, the worst thing you can do is have an automation try to remediate, and then the on-call person is stuck with, I'm sorry, I don't know why this automation didn't work out for you. And so you're really a lot better off doing that 80-20 relationship where you leave the parts that are, changing quickly and, very, very product dependent on the human, and then automating things like making it faster for them to restart servers or, move traffic to a different data center, et cetera. But, I think part of where you started this whole conversation, Stephen, was, what is that pathway towards this dream of
Absolutely.
Automated state? And I think that the path is what is automation? automation is a codified process for machines to execute. But what does that look like for humans to do that? Well, that's documentation. Documentation is fundamentally a codified process for humans to do things. And so how do you get to the point where you can have a machine do it? Well, step one, maybe you should document it and have it documented and tested with humans and reliably consumed. And then over time, introduce these small chunks, again, to that 80-20 split of automation that's mixed into your documentation. And so, a human could be following along, and the dumbest example of this is, a Confluence doc pointing to a script that humans could run, and slowly increasing the amount of scripting that happens. But then, the other aspect of the fear of automation is oftentimes when these live as scripts, it's not fundamentally the collaborative environment for building automation that we have in all this other tooling. So sometimes people have their own copies of scripts on their machines, and it may or may not be up to date. There's not really an easy way for people to have that documentation and the commentary and the code review and all this other process for that automation. So I'd say the other piece is have a SaaS service in a hosted environment for the automation to run. It's what we see with things like Terraform Cloud becoming, or these managed Terraform solutions where, or things like Circle CI for doing your deploys, having consistent environments to actually run this automation, so that it feels more trustworthy. You don't have to worry that, oh, this time because I upgraded my Python, on call pages and the script now fails due to some Python error, which happens for us all the time.
And I'll just highlight, number one, thank you for the chat, everyone that's chatting, and I'll be sure to ask some of these questions in just a few minutes. So if anyone else has questions, please feel free to add them into chat. I wanted to point out Matthew Zier's comment. I hope I got your name right, Matthew. Saying also dumb on that same topic, Tina, is a release process that includes a Google Doc with JSON blobs to pass into curl, which no one remembers how to do, of course. So very much in the same sort of theme of these things aren't sort of perfectly solved by any stretch of the imagination.
So I have to interject and say there's a very famous outage where, of course, in the Google Doc, when you type open quotes, it might get replaced with the Unicode smart quote thingammy, and that's not a valid delimiter in Shell. So you copy and paste that in, and things go thud.
That doesn't make sense. It's funny to hear about. It's funny in a kind of a morbid sense to me to hear about other things that we actually do to keep services running. Google's such an advanced organization, and yet, smart quotes sometimes defeat us.
Well, it's somewhat of a sideline, but I think one of the other reasons that people are sometimes scared of automation is that control planes, global control planes, extremely smart automation, which solves 99% of the problem space, however you would manage that, then occasionally goes awry, and global control planes going awry have been responsible for a number of GCP outages. And organizations that don't have a global control plane don't have that problem, but they have the problem of paying the maintenance cost for having to federate out their control planes generally. So anyway.
Sure. That makes sense. I kind of wanted to dig into one of the things that Tina just talked about, which is sort of, there's always this need to have humans in the loop, right? If we had perfect systems in some abstract notion, like automation could fix everything, but there's always these exceptional cases, like downtime is like an exceptional situation that probably we think needs humans to, be part of that exceptional solution. If it wasn't exceptional, we would already had it fixed by code somehow. That sort of scope of thinking. And so a lot of struggles in the SRE organization I've heard are around defining like the right boundaries between automation, scripting, those kinds of things, and having humans have the right information to step in and not have the system perhaps even fighting against them. There's been a couple outages that have been prolonged by the automated systems actually doing the wrong thing, or doing something unexpected that humans couldn't reason about in that exact 2 a.m. page kind of thing. So how do you decide what things should be automated or could be automated, and what could be done or should be done by a human? And, what are your criteria for those kinds of things? Maybe I'll start with you, Niall, if you have any thoughts there.
Yeah, so I guess there's a couple of frameworks that would allow you to make those decisions, with the key point being that anything that you're doing should be something you can reverse that decision relatively quickly, or you're not entering into a 1.5 year kind of death march style situation for some automation. You emerge the other end, and it turns out you switch providers in the meantime. Like my overall intuition in the area is automation should be coupled to, in this framework, right, way of understanding the situation, automation should be coupled to activities you find yourself doing a lot. For some hand-waving definition of a lot, but you could probably survey people and stack rank stuff and look at commands executed and so on. You say, we seem to move data from here to here a lot, and actually that's probably some class of primitive operation which could be effectively automated. And in many cases, you can get a significant benefit from that, not just from the removal of kind of human time, but you can also make it more efficient and have it run in the background and have it run at night when people aren't around and so on and so forth. So there's, typically speaking, some pretty good return to those kinds of activities. There's a famous XKCD cartoon which attempts to show some graph or table of the trade-off between how much time it takes versus how much you should automate, which I do not think captures the full value of automation, and I've said that before. But that's one framework. Another framework kind of revolves around, like for any sufficiently complicated software system, you can draw arbitrary boundaries at very different places and have things that move from being automation to being part of the product and maybe even back again, etc. But I think another visionary point, really, I mean, so many people think of automation as kind of meta code or stuff that's less important and in the background of the product, particularly from a product engineer point of view, but actually from an operational point of view, from an operability of the system point of view, that automation, if it's treated entirely separately, often doesn't have the same kind of code review quality style thing Tina was talking about earlier. That's also a misfeature. That's also a kind of a cultural misfire of attitudes towards automation. In some sense, the highest quality product is one which is autonomous, where all of the concerns that you would automate have either been brought back into the product and are now product features and don't have to be maintained separately, which introduces the possibility of drift and decay and so on. Or they've been designed so that the problem doesn't actually occur again as a feature of architecture. I think that people are, or a lot of software developers today find themselves on the microservices train, for want of a better word. And so the idea of taking a complicated problem domain, decomposing it, having intercommunications, all of these things allow the separate treating of problems which are hard to do in the monolith case, but end up creating a whole bunch of other problems around observability, externalizing your call stack, and so on. Automation is harder in the microservice case than the monolith case. But the kind of problems that you hit against in the monolith case are often things which are insoluble in that paradigm, because there is a limit to how you scale. Anyway.
That definitely makes sense. And Tina, I wanted to ask you the same question. Do you have any thoughts on how to keep humans in the loop effectively and how to make sure that human in the loop involvement goes well in these exceptional cases?
Yeah, I mean, I'd like to start kind of with that second framework that Niall's mentioned, of this notion of, automation being this back and forth between, something that lives externally and then gets pulled back into the product. Part of where you started this conversation and this question was, how do we think about what should humans be involved in and what should be automated? And I think a very simple way of thinking about it is, we can only automate what we can understand. So oftentimes, I talk to people and then they fixate, or they say, what about the ideal world, Tina, when everything can just, isn't the goal to have everything automatically remediated and taken care of for you? And in some ways that would eventually be, you pull that all into your product and therefore have no outages. Well, I think unless your company has been purchased by a private equity firm and has halted all future feature development, the reason we have outages is likely or hopefully not because of, as Niles mentioned earlier, the alerts that we are afraid to shut off, but a lot of the incidents or the alerts and why you're paged is fundamentally because it's something in your system that's new and you have yet to understand. And so, step one of that is to have very intelligent humans walk through that process, and they have to be able to pull in all of the right context and the right information that they need to debug the situation and on the fly figure out what's going on. Then only when a very, very intelligent human can figure that out and you have some understanding, can you start to do that next layer, which is I'm going to write some documentation so that maybe someone who has less familiarity with the system can also follow these rules and move into it. And then, only when that happens can we start looking at that 80-20 split and say, okay, what are the things that humans are reliably done every time and consistently done by a human? And let's take those chunks and automate those, and that's sort of the journey that I like to think of as we talk about, the path towards humans and automation. And so, I often say that the goal should really be more, how can we make humans that are on call, less error prone and more efficient? Because the idea that the goal is to make those humans replaced with automation can basically never happen as long as the product is continuing to evolve and you have these new areas of uncertainty that you have yet to understand.
And Tina, that's a great segue into some audience questions here that I'll start asking. I still have plenty more for you, but I thought we'd give our audience a chance too. So I'll start with this one from Kantu, which is how do you characterize that level of maturity of automation, starting from zero kind of thing, like humans have to do every single action in the to serve the product, versus going up from there? And then how can teams move up that maturity level? Sort of a two-part question from Kantu.
Yeah, I actually think that the better way of thinking about it is, what's the maturity level of the team's process? And so, that you don't have this concrete line between human process and machine process. So that includes human process, which is the amount that you've documented repeatable steps that someone can take, mixed with machine process, which is code that automatically runs to do those things. And so honestly, I think that a team in an organization that has a fully documented human process is potentially more mature than the team that has small bits of automation strewn about with completely undocumented human process, right? And so, I think the first framework is, how can I talk about the maturity level of my team in terms of repeatable process? And then it's like, how efficient and how error-proof is that process? So the amount of automation that you need is really only a question of, how much is this costing to have a human do this? Because it's time consuming, it's keeping you up at night, et cetera. And how much is the human injecting errors that actually cause even further incidents and more outages?
That makes sense. Now, do you have any thoughts on that, sort of that journey from humans only to automation?
Yeah, again, there's a couple of different frameworks you could use. One of them, I mean, in classic SRE book fashion, would be eliminate toil. So the question is, what are you doing today across the folks in your org who are doing toil? What kind of proportion of time are they spending doing this? And stack ranking by that in order to find out what to automate. But I think the question is more about You might add a little to the question if you think
Sure.
of it, Cantu, later in the chat. But characterizing levels of maturity of automation is also a question about the capability of the team, the capability of what they can author from a software perspective, as well as an observation about where they spend their time today. And so, like, I have various issues with maturity models. I think maturity models are most useful from a perspective of, okay, we're at 0, like we're literally not doing this at all. What does 1 or 2 look like, right? But I think that beyond maturity level 3, and I've sat in so many meetings where we put up the maturity matrix model and we're all like, oh, I hope we get to 5. Like we never will. But there's specifically a problem with, if you're at maturity level 3 in axis X, what does that mean as opposed to maturity level 4 in this other axis? Like, would you rather have that level 4 or that level 3? Like, there's no framework, consistent framework for understanding that today. So anyway, I didn't answer your question, Cantu.
That's okay. I'll say for him that's okay. It was an interesting conversation anyway. But I'll ask a second question from Cantu, just because we're sticking with him for a second here, which was kind of more specifics around the paid advertisement you gave earlier, which is how have you seen teams and organizations successfully build up more deterministic alerting? So alerts only fire when they violate an SLO, going back to the conversation of, very high CPU use might mean everything, it might mean nothing, but you don't want to get paged in the middle of the night in all those cases.
Yes, lots. I mean, actually, that's the good news about some of the pivoting to SLO-based approaches I've seen across the industry in the past while. I won't say it's a deterministic process at all necessarily, but it's eminently tractable. You build what's called, one way of doing it is you build what's called an outage footprint mapping, which is a mapping between incidents and the alerts that fired, and severity of the incidents in particular. So you can say, oh yes, this terrible thing happened and it flowed from these 5 alerts, and these not terribly terrible things happened and they flowed from these 17 alerts. So you over time end up by tagging or coming to realize that certain kinds of alerts actually just aren't that important in terms of real business impact. And so you can end up deprioritizing them in various ways. Now, the nuances of this depend on the monitoring product you're using and your kind of political state of your team and so on and so forth, but it is 100% tractable to phase out less important alerting. The real trick here is to start the SLO alerting and maintain the symptom-based alerting, CPU high, in the background, and then successfully wean people off the noisy stuff and onto the real stuff that matters, which again is tractable, but it takes some time.
And Niall, what would be a good resource to look at for more information on that process?
Well, I'm glad you asked me that. Actually, without referencing that unpaid advertisement of earlier, there's quite a lot of useful material in the SRE workbook and Rob Awaszczuk's Philosophy on Alerting, which is a publicly available doc, and a bunch of the work in the observability space that Charlie Majors and others have done. So actually, there's quite a lot of that. Use your favorite search engine.
Sounds great. Thank you. And Tina, I wanted to go back to you and ask a question around what's a popular topic here, around automation, human in the loop, and getting the right boundaries and that sort of thing. We have a question. It begs the question about how will the adoption of machine learning evolve for these DevOps use cases? What kinds of companies will see what kinds of benefits from machine learning based approaches to SRE and DevOps, do you think?
Yeah, I think that the thing that's really interesting about machine learning is, in order for machine learning to do anything useful, it requires collection of good data. And I think that the real problem, and this both affects machine learning, but also even, the previous question from Cantu around, how do we reduce the level of noisy alerts, is right now, SRE operates on very, very minimal data, especially when you consider that it's an engineering-driven organization. So, the metrics that we're looking at are things like your SLO. Most people track MTTR, so that they know when, the amount of time between the alert going off and the alert being resolved. But rarely do we track anything in between that, such as, what runbooks people use to address various alerts. What commands did people call? And so I think step one is whether or not the process is human or a mix of human and automation. The really important piece is to start thinking about all of this as a data problem. Let's try to start collecting the data for what happens during an incident, and not just during an incident, what's happening with everything in your operation ecosystem before the incident, and what are all the steps for, after your postmortem that you do after the fact. And so at Transposit, that was actually the motivation for when we introduced the idea of smart runbooks with pluggable actionability as, my minor plug. I feel like I get one paid advertisement for everyone that Niles makes. So, with our runbooks, a lot of it was a question of how can we, use what we've learned from consumer products to make user-centric approaches to gathering data that will then help you improve the reliability of your systems. And we did that through having interactivity in the runbooks so that we'd have more signal about what runbooks were used and how effective they were, and then having actionability built in so that we can know what scripts were run, how effective were they. And so you start to have this world that you can then imagine applying machine learning to say, hey, when this alert fires, these are typically the runbooks that are used. These are typically the actions that SREs take. And one of the nice things I like about this too is, it almost allows you an eventual future where you can gamify the creation of runbooks. You often, one of the questions that we hear a lot is, how do I get my teams to actually write and want to use runbooks? And once you have this data, you could imagine giving kudos to the person who wrote the runbook step that is used to triage this particular incident. And so all of these are just ways of taking something that has traditionally been viewed as a top-down process that we have to beat into our ops and engineers to actually document and write, and then to hand insert the data, usually through some tedious postmortem and in an unstructured way that is hard for anyone to, or any machine to analyze, and instead build systems that natively capture this data.
That makes a lot of sense, and it raises a different. I meant to say earlier. I hope I get your name right. That question was from Rajesh Babsar. So thank you for asking that question. And if anyone else has other questions, please feel free to put them in chat as well. We'll continue to go through them. But I wanted to dig into that question of runbooks and collecting the right information and that sort of thing. I know we had an interesting conversation about this before. One of the challenges is that runbooks always sound like such a good idea, but they're almost never used at 2 a.m. when they'd actually be most useful, supposedly, to people to use them. How do you think about, why is that the case today? Well, first of all, do you agree? But why is that the case today? And what can we do to remediate that inside of an organization? And I'll pose that open to either of you, I suppose. But Niall, I know you have a take on it.
I'll let Niall kick it off. I've already talked a bunch about runbooks.
So I suppose first thing to say from my point of view, I'm a strong believer in the value of documentation. Perhaps unsurprisingly, as somebody who has written a lot in the past, I view that words are important and useful. Okay, fine. From my point of view, engineering as a whole benefits from and almost requires that you communicate about your work, and you communicate about the properties of your work and the properties of the systems you're working on, and so on and so forth. It's really a cultural problem at the end of the day if a thing which will lead to more successful outcomes is not done. Like, is it not done because it will lead to more successful outcomes? Like, that seems untrue. It seems more like it's a prioritization question. I would do this, except I've been asked to ship this feature as opposed to this other thing. Or I would do this, except I like English is not my first language, and so I struggle when writing English rather than code, etc. So there are organizational supports available, in my opinion, for all of these things, including but not limited to kind of tech writers, incentivization of various kinds, code review. I think the big thing in the discovery of, or the recent discovery that you can actually have lots of documentation live in parallel with the code, and so it's easier to maintain. I think Rihanna McNamara of the Google Tech Writing team has a good talk on this. There are ways to approach this which don't just involve kind of throwing up your hands and surrender and paging the senior person on the team who always knows how things work. Like that's organizational dysfunction. And so to remove organizational dysfunction, we organizationally support the right activity. I think for runbooks in particular, having written a few in my time, it's the skeptic's argument against them is really that, well, you wrote this in 2007 and now it's 2020 and it's no longer relevant, so it's leading people astray. So if people follow this, they'll make worse mistakes than they otherwise would if they had to reason things from first principles. That's often what I see as the counter argument to documentation. I think not in every case does more context lead people astray. Not in every case does useful commands lead you astray and give you things. I think what is harmful is not the existence of the documentation, but people using it as if it was unquestionable. A more responsible attitude to the truth value of the various sources that you're dealing with when you're attempting to debug or resolve a production question, that's the mindset to instill. And yes, runbooks can be wrong, of course, but so can any other kind of information, including the senior person you just paged in order to get them up to fix the problem. So like I'm just not convinced about the validity of anti-documentation rationales.
Makes sense.
Yeah,
well, maybe,
I'd like to add a few pieces to that, actually. When Niall's mentioned a lot about sort of the cultural problem and the idea of runbooks living closer to code and being more part of that process. One of the things that I've been trying to champion a fair amount is this notion of making the analogy between unit tests and kind of operations as part of that, developer cycle. So, there was a world before there was automated testing where, people were, I remember back when in the early days were like, you expect me to write tests with my code, but now that has culturally shifted such that engineers, as code reviewers will say, hey, where are my unit tests? And so, I think about things like, can we have the same notion where just like we have test coverage as a metric that we follow as engineers developing the product, should we also have the notion of runbook coverage such that, part of the code review process becomes, hey, did you write the runbook documentation to go along with it? But in order for this to work well is exactly what Niall's mentioned, which is for that to happen, you also need some shifts in how we actually think about runbooks. It only works or makes sense to have runbook coverage as part of, a code review if the runbooks live in code. And so, I'm a big proponent. This is what we do at Transposit. This is what our product does. Is runbooks should be, in Git repositories. They should be something simple like Markdown. But part of that is so that you can actually have runbooks as part of the cultural process of developing code.
And maybe just to tie into that, Natalie had an interesting comment or an interesting question, which is, do you have any suggestions on running automation to validate the runbooks themselves during things like chaos engineering to make sure they're up to date and valid, those kinds of situations? Have you seen that done in practice? Any suggestions or best practices there? And I'll open it to both of you.
I have not actually, I don't know if Niles, you've seen this. I haven't actually seen anyone do this well, but it is something that we hear from our customers a fair amount is, hey, you have this really, really interesting runbooks product with integrated automation. Well, this would make a great tool for training and testing for my engineers. If I could, you know, have a sandbox deploy, have my runbook and the scripts, you know, pointed at that sandbox, and this can actually be a training ground. And so I haven't seen this yet, but I think it's a really interesting area for exploration.
Got it. And maybe a kind of a more specific question coming from Oleg. It's often told that SRE people should spend 50% of their time writing code. Do you think that's true? And do you think it's do you think that using a DSL like Puppet or Chef or Terraform should be considered that? And why? Like, where does that recommendation come from in the Google SRE book? And what does that indicate to you about this culture that should be driven? And I'll open it to both of you again if you have any thoughts.
Yeah, so I guess there's two things to drill down on there. The first one is it's not necessarily 50% of their time writing code. By the way, it's 50% in project work, and the idea of the project work, which might be implemented by 99% writing code and 1% talking at the water cooler or whatever it is. But the idea is that the project work is how you make tomorrow better than today, in Damon Edwards' phrasing, with the idea being that a large number of operations teams are not in place in order to make tomorrow better than today. They're there just to absorb the pain of today and essentially absorb it and wake up tomorrow and do it, which is why like there's quite a high turnover. But the idea of the SRE model is that you limit the amount of pain that you'll suffer under that heading and spend the rest of your time on making tomorrow better by having projects to take away toil, do SLO alerting rather than tactical alerting, etc. Now, Oleg says, do DSLs qualify here? To my mind, the central question is, are they making tomorrow better than today? Is the Puppet, Terraform, etc., going to make it easier, quicker, less costly, whatever angle of optimization you like, to achieve specific task X tomorrow? If so, sure. Like, I don't really care if it's HTML or Python.
Yeah,
from a like language point of view. Don't really care if your AST is a DOM or not. But I do care that it's making tomorrow better than today. And so I suppose that there are specific nuances as to whether or not you're learning Python to wrestle with a problem set rather than Terraform. But actually, so much of this stuff is blended today, and you manage configs by writing code to generate the configs, so on and so forth. Like, I just don't see a hard boundary there anymore. Like there might have been a decade ago, not today.
I'm almost in full agreement with you and everything you say about the notion of Terraform being just another language and another element to the stack. But I have seen at least one thing that has really changed with the advent of things like Terraform. You know, I mean, I'm a huge fan of infrastructure as code. I love that it's reliable, reproducible, etc. However, you know, we've gone from a world where, you know, when you're on call, you just go to AWS console and, you know, maybe hit some buttons in a nice UI, to a world where ideally you make those changes in Terraform so that you don't forget what changes happen, right? And you have that sort of rigid structure around it. But the reality that I've seen in almost every org that I've been in is that is a somewhat domain specific skill set. You know, we know that we live in a world where SREs and engineers, you know, share the burden of operating and being on call. And so I think it's a little bit untrue to say that being able to modify Terraform is the same as, you know, a Python script. I feel that most of my engineers would feel a lot more comfortable looking at a Python script and figuring out what it's doing versus, you know, especially if they've never used Terraform, to say, okay, there's an incident and I need to both know how to write the Terraform change to make the modification that I need, but also I need to feel comfortable enough to do the Terraform plan, the Terraform apply, and make sure I don't screw anything up. And that's also a skill that, depending on where in the stack you are as an engineer, you may or may not do as part of your day-to-day job. And so that becomes this area where you have engineers doing things as part of their on-call rotation that they may not feel as familiar with because it's not part of their everyday development cycle. And I think the more that you have that, the more I think automation has the potential of serving as an abstraction, so that you kind of level the playing field, and you can turn some of that Terraform coding change that you'd have to do while you are on call to scripts or some sort of automation.
We'll let that one. I like the disagreement. We can leave it there for now. I wanted to. I thought this was a great question from Mike Geggy, who says, "I like the idea of only alerting on important issues like SLO violations, but connecting these threads together. How do you link those kind of those kind of unspecific SLO notifications to actionable runbooks that an engineer or a SRE could actually take and execute on call? How do you think about blending those two challenges?"
Yeah, so the first thing I'd say is SLO alerting goes hand in hand with observability. There's an earlier point in the earlier question in the chat about observability for thick clients, which I think is also interesting to get to. But SLO alerting, I think I would quibble slightly with something as unspecific as SLO violation. SLO violations are hugely specific because they are based on a metric, and that metric is connected to business like outcomes or user experience in some way. So to say, I think it's a bit more nuanced than that. I think when you get an SLO violation alert, it's about a metric. It's not about CPU high, it's about user latency as measured from the client over the past half hour is such and such, and it should be such and such, right? And that gives you a starting point in the first case, which is, okay, latency, right? What could be contributing to latency? And that's where the observability piece comes in, because you need to look at how the system is operating. And in many cases, I should point out, today with tactical alerting like CPU high or whatever, we like to imagine that those alerts are actually good proxies for the behavior of the system or the incident, the sponsoring incident, I suppose. But actually not necessarily, because CPU high could trigger higher experienced user latency, but it could also be, for example, disk latency making the database slow, which contributes to this as well. So a variety of tactical alerts won't necessarily help you go in the right direction to resolve this. But it's a combination of stronger observability and tighter understanding of the metrics.
You do have any thoughts as well?
Yeah, I was like, Niles, I don't know if you had this when you were at Google, but something that I saw a lot when I was there, and I have not really seen in any organization since then, is, at least we were aspirationally of the sort that we had a run book per alert, or that was sort of the framework and the goal. And, when we talk about how do you make like run books much more integrated with the alerts, I think that's like step one. And I think very few organizations do that. The obvious challenge with that is when run books are just flat documentation or Confluence wikis, that system is very, very cumbersome. And so I think that's where, we need better technology around runbooks, technology that supports the idea of almost embedded elements, and you're able to scaffold from these more generic runbooks. That is, how do you go from, okay, this alert means I need to, make this change in this database, and that's, embedding in the content of, another runbook that's shared across a bunch of different alerts for how to manage the database.
Sure. That's been a great discussion, and I think it's a really interesting. As you look forward, sort of into the future here, as you know, how do you, as stacks are evolving, as organizations, as you mentioned earlier, Tina, they're constantly changing. The problems aren't generally related to yesterday; they're generally related to today and tomorrow kinds of challenges. How do you think about making sure that your automation strategy or your runbook strategy? We talked a lot about the cultural side of it, certainly. But how do you think about making sure that automation and all those runbooks stay up to date in a fluid system when every products changing all the specs every day kind of thing? It always feels that way. How do you think about making sure that's robust and sort of ironclad so it's not causing you even further challenges down the line? And I'll ask you first, Tina. I'm sure Niall has ideas as well.
Yeah, I mean, I think, for me, I don't think I have anything that I haven't already touched on so far in this conversation. I think that there's a huge cultural aspect to it where you need to integrate it as part of the coding process to do runbooks. But the other piece is, we need to start thinking of how to collect the data about how effective these runbooks are, because that's also part of what can help drive the cultural change, is just having more visibility into what's happening. But then, going back full circle to the theme of this talk, it's really about sort of having that human in the loop automation piece. With ever evolving systems, I think the mistake is to automate all the way to the top on items that are evolving very, very quickly with your product. That's an area where it's much easier to just let the human be in charge of that decision-making process. So to some extent, focusing on having, flexible run books that allow for the human to, kind of going back to, do run books go stale? That assume that there's some human judgment involved, and that intelligent person's reading this will, help you guard against that run book becoming stale. And similarly, scoping down the automation into these smaller chunks that the human is sort of in charge of navigating through is also a way to keep your automation from going stale.
Makes sense. Now, do you have any thoughts on it as well? And then if we don't have any other questions from the audience, I will close it out by asking one forward-looking question, which I'll preview right now, which is, what do we have to look forward to in the next 5 years of DevOps and SRE automation? But first, Niall, do you have any thoughts on making sure that organizations can continue to receive the benefits of these while reducing the costs, I suppose?
Yeah, I think, to follow on briefly, I think there's a few tactical things you can do to help keep stuff up to date, which is one of the major complaints you were talking about there, Tina. I've been in teams that did quarterly runbook fixes or fix-its. So every 3 months you sit down and you spend a week or like 3 days in the middle of it and say, okay, let's just go through each of these in order and go, is this relevant or does it need a tune-up, et cetera, et cetera. You often can gamify that in some way as well, prizes, etc. If we are motivated by things like swag rather than the satisfaction, the glowing satisfaction of a well-optimized service. There's a bunch of cultural and other organizational approaches you can take to maintaining that. But really making it easy to do that is probably the #1 contribution you can do. And every frictional step that you introduce between editing code or editing config and also updating a runbook or documentation at the same time, each frictional step is kind of like a funnel which will strip out some of the people who otherwise would have done it if they'd had the time. So a low friction organization is one which is best placed to handle this kind of problem.
Makes a ton of sense. So let me close it out here with one last question for both of you. When you look into the future, what do we have to look forward to in the next 5 years? What are we going to see? What are you hopeful about? What are the next challenges, perhaps even? Tina, I can start with you.
Yeah, I mean, I think that it's crazy to think that it's been, almost 15 years since Google first introduced SREs and that whole concept. And, I think Google is its own kind of microcosm of what we're talking about, the path towards automation. You know, they started with highly skilled engineers as SREs. And that was great. I think that what that really did was showcase the power of what this role could do. But, you know, we've hit this time in this place where, you know, we can't hire enough highly skilled SREs, especially as the scope of what technology covers is ever increasing. And so we're at that critical junction where I think it's exciting being in the space of building products for DevOps and SRE. We're seeing a lot of competition here. And so I think the exciting piece is we're having lots of platforms that are really trying to lower that bar so that you can have people who are required a much looser skill set to be able to do the same sorts of activities that SREs traditionally have been able to do.
Makes sense. Niall, any thoughts about the next 5 years?
So I suppose the first thing I'd say is the first 6 months of this year didn't really give me a whole lot to look forward to. In that
That's
way,
worth noting.
Yeah, which I think probably will inform some of my answer. I think like everything about the last 6 months has shown that online services in general are increasing in importance, perceived importance, real importance, and the sophistication of what is going to be done on those platforms and the scale and so on and so forth is going to increase. So you would therefore argue, or seems plausible, that more SREs, more DevOps folks would be required in order to do that. And I think that's true. I think one of the things that amazes me and amuses me in kind of equal measure, being partially responsible for this, is SRE as a thing is out there in the world, and pizza companies have SREs, like not just fintech and tech and like cloud providers and stuff. There's pizza companies and cement companies, and all of these kinds of folks are kind of using, in my opinion, incorrectly, right? I had a minor Twitter storm about this a week or two ago. They see the term SRE and they go, in their head, they read somebody who's competent and on call. And I actually think we have to move away, not from the idea of competence, but from the idea that we're looking at SREs as individuals who are coming from the operational domain and growing up to product engineering or real software engineering, because actually the origin story of SRE is about engineers who are just engineers like the rest of the engineers, except they happen to care more about the operational kind of consequences of the product. In this case, the search engine, as was, right? But it's to my mind, everything we can do to break this fixation around on-call and the twitchiness around paging, and just so much of the senior decision makers have frameworks which are basically pretty unhelpful when it comes to making good quality decisions about how to organize work around running online services. I think that's the job of the next like couple of decades, never mind 5 years.
Well, let's leave it at that then for today's conversation. I really want to thank you, Tina, and you, Niall, for all of your time here, spending time discussing the future of automation here in the DevOps stack. I hope our panelists have had a fun time, and I hope each of our participants have also had a chance to ask their questions. If you have any follow-ups, please feel free to reach out to Michael Martin, who is in charge of this event. Michael, do you have any final words to say here?
I do, yeah. Thank you so much for everyone for joining. As Stephen mentioned, yeah, we'll be doing a follow-up. I'll follow up with just a quick email, make sure that you're all connected, and we can share the recording of this event. And similarly, Ashley from the Transposit team, Ashley, do you want to wave your hand here? Thank you. She'll be following up with a comic white paper that they just put together. We're excited to read that. We'll give you more information about how you might be able to learn more about what they're up to and working on. So with that, thank you again for joining. Hopefully you enjoyed, and hope to see you at our next event, date TBD, but coming up soon. Thanks everyone, take care.
Thank you so much. Bye-bye.
Bye-bye.